All right, here's the second part of section 2.4. These are the word problems that are here on the top of page 49. And so what is so important is that you're able to draw a picture of what's going on that represents this type of work that we're doing. And so let's take a look at these first few. A guy wire is attached to a 100-foot tower that is perpendicular to the ground. The wire makes an angle of 55 degrees with the ground. What is the length of the wire? And so here's our 100-foot tower. And the wire is making an angle. So here's the ground. And let's have our wire just coming off here to the left. So this is the wire right here. Because the tower is perpendicular to the ground, we're getting a right angle, and they're saying that this is 55 degrees. So they would like us to know the length of the wire. I'll call it x. No problem. We can use trig to help figure this out. Now, because they're giving everything in degrees, make sure your calculator is in degree mode. And so what do we need to do? We need to realize that, okay, I'm looking at an angle and know the opposite, but I want to find out the hypotenuse. Well, no problem. I know that then the sine of 55 degrees would be equal to the opposite, 100, over the hypotenuse, x, what I want to find. So if I move x over, I'll show all the work here. But we know that you're algebra proficient, right? So we don't have to show everything. But I will show everything because I love you. Sine of 55 degrees. So we got 100 divided by sine, and I'm double checking that I'm in degree mode. Otherwise, I'd be doing 55 radians, which would be completely different. And we get a nice height or length of the wire to be 122.07. So I'll just say that that is, there we go again. Sorry. I really apologize for that. I keep hitting that thing on the side. But it's not worth it to start over. 122 and everything was in feet. So I'll try to be more aware of where my hand is. That's it. You're done. A fire is sighted at the top of a tower in Wayne National Forest. Way to go, Wayne. The ranger found that the angle of depression to the fire is 22 degrees. If the tower is 75 meters tall, how far is the fire from the base of the tower? No problem. So there's some things that you want to know and that are going to make a difference when we draw this picture. So first of all, we have this tower. That tower is 75 meters tall. So we got 75 meters in height right there. And it says something very specific, the angle of depression. So remember what the angle of depression is. Let me come in here with a different color and maybe stay in a different color. This blue line is a horizontal line. Angles of depression are always off of a horizontal line. And if I continue drawing what's here, I'll go back to the green since I started in green. Here is the angle. The angle of depression is 22 degrees as he looks down, and here's the fire. And the question is, how far is the fire from the base of the tower? No problem. I know the adjacent, and I want to find out the opposite. I'm just thinking about SOHCAHTOA, so tangent's going to be involved. Tangent of some angle is going to be, well, what angle? Well, let's find this angle right here. We can find that. Tangent of that angle would be opposite over hypotenuse. Well, what is that angle? If it's 22 degrees from the green line to the blue line, well, it's 90 degrees it's 90 degrees right here, right? We know that that's 90 degrees. So the makeup, this angle right here, and let me come in here with a different color so it doesn't seem so confusing. It is nice that I can write like that, but we definitely know that this angle right here is 90 degrees. And so if I take 90 and subtract away 22 and get 68, I must have the degree measurement that's in there. Whoops, I meant to change the coloring of that, but that's fine. So this is 68 degrees. No problem. You can see what x is. X is 75 times the tangent of 68, and trig can really help us out. We don't have to go to the full Pythagorean theorem and know two sides, as long as I know an angle, and that's actually going to help us out in other sections. Now, what's special about all these problems is that they're all off of right triangles. The question is going to be, well, what if it's not a right triangle? Well, that's why we're pushing chapter 7 right up here, so you can see that. So if you take 75 times the tangent of 68 degrees, making sure you're in degree mode, I'm getting a distance of 185.6 meters. That's how far the fire is away from the tower. A surveyor is 100 meters from a building. Okay, so let's draw the surveyor. Hey, here, let me switch to a different color. I'm tired of the green. Maybe you are too. Okay, here's our surveyor. Hello. Okay, and he is 100 meters away from a tower. Okay, from a building. Right, so here's the building right out here. If the surveyor's eye level is 1.55 meters above ground, find the height of the building. So I apologize, I skipped something. If the surveyor, he finds that the angle of elevation to the top of the building is 23 degrees. Well, he's looking right here, and remember, angles of elevation are always off of the horizontal. And he's finding this right here is 23 degrees. And the building's 100 meters. We're 100 meters away from the building, so this is 100 meters right here. So let me get rid of this bottom line because it's been translated up top. And what we know is that this is 1.55 meters down here, right? From the eye level down to the ground is 1.55 meters. And the question is, how tall is the building? Well, I want to find that. Once I find x, the building height is going to be x plus 1.55. Well, that's fine. It's kind of like the last one. I know opposite and adjacent, they're involved in it. So I'm going to look at the tangent of 23 degrees. And it must be equal to opposite over adjacent. And so what's that imply? It implies x is simply 100 times the tangent of 23 degrees. And 100 times the tangent of 23, you can see it's just like the last one, is 42.4. Now they have it out to the hundredths, so I'm going to go out to the hundredths. 42.45 meters would be out to the hundredths. Well, that's not the height of the building. Sometimes I'll get students to be like, I don't know where they came up with their number. I got 42.45. Well, that's because you forgot to add in the distance from the eyes down to the ground. And so if we look at 42. Sorry, I didn't get my decimal point in there. 42.45 and add to that 1.55, we get a nice 44 meters. That's the height of the building, is 44 meters. Done just that nicely. The last problem that we're going to do is this one. I know there's a second problem down here, but it's talking about bearings. Bearings is a 2.5 problem, and so you'll see that done in that section. So there's no reason to do that problem here. We're not prepared for it because we haven't learned about bearings yet. So from the top of a lighthouse, the angle of depression to a buoy is 25 degrees. If the lighthouse is 150 feet above sea level, okay, so here's 150 feet. And the angle of depression, let me come in here with another color. There's my horizontal. The angle of depression is 25 degrees. And here's my buoy. Right, it's a buoy that we see, right? And they want to know, find the distance from the buoy to the foot of the lighthouse. They want to know this. Well, what do we know? We know that this angle right here is 90 degrees, and 25 of it is taken up by the depression, so the remainder, 65, must be inside that triangle. Perfect. Again, opposite and adjacent are known, so the tangent of 65 degrees has to be equal to x over 150. And it's the same problem again. X is equal to 150 times tangent of 65 degrees. And what's 150 times the tangent of 65? 321.67. So 321.7, and everything was in feet. That's how far that buoy is from the base of the lighthouse. So that's your additional 2.4 styles of examples. The homework should mirror that. It's not going to mirror it perfectly. You're going to have to put some thought in there, but draw the picture, spend some time doing that, and you'll be successful.